Java collection framework, sets. We're going to be talking about sets. So a set in the Java collection framework is just like a set in math class, right? A set of things is, a set of things. And the key is that it has no duplicates, right? So the big thing about the sets is that a set has no duplicate items. So a set of integers, can only have the number one once. The number two can be at most once in there. Number three can be at most one time there. And these are very useful, right? So let's say you're reading a file and it's got a bunch of phone numbers, and the file has repeated phone numbers, but you just want to get the unique ones, right? So you can use a set. You can read all those numbers into a set. You can add them, and what the set is going to do is, if the number is already there, it's just not going to add it again. So you're only going to end up with one copy of each item. So the Java interface is called set, S-E-T, and there's three classes that implement that set, at least three. The three main ones: HashSet, TreeSet, and the LinkedHashSet that they come with the Java collection frameworks. The way you use them is, let's start with a set of strings, right? So you say, I want a set of string, I'm going to call it set. It's a new, and then I have to pick my implementation. I'm just going to use the HashSet for now of string, like that. And then I have to import these classes, right? And import my Java HashSet there. So I got the import statement then, and then I can just add Alice, Bob, and Charlie. So there they add it, and then I can iterate over this. I can use the built-in, iterate over a collection as such. So I want my iterator to iterate over the set. Change that to name, and there you go. Name. Run it, and they come out. Bob, Alice, and Charlie. Now, okay, first thing is the little yellow lines. I can change the type to iterator string, and then I can get rid of this. So this makes it a little bit cleaner, because we're using templates nowadays. So yeah, this is how you iterate. You see, I can get an iterator using set.iterator that returns to me an iterator of string. I can use the while it has next, I can get the next item out of it, and then I just print it, and that's what that does. You see, to demonstrate, I can add, if I add Alice twice, like that, and run it again, you see Alice is only once. And it doesn't really matter how many times I try to add it, she only appears once. Similarly, I can then remove, right? So let's remove Bob. I can remove Bob, then when I print him, he's not there anymore. Notice that if I try to remove something that is not there, I don't get any error. It just, it's fine, whatever, it just keeps going. So I can remove things that are there, or I can try to remove things that are not there. It's not going to crash or anything. It's just going to ignore that. Add remove, and then contains is the other operator. Set.contains, this is probably the one kind of the reason you might be doing this is to check if, after you read everything, put Bob back in, to check if it contains a particular item. So Bob is there, and it's going to be a boolean. It's going to print out true or false, like that. Let's say Bob is there, true, right? If I change Bob to Bobby, say Bob is there, false, right? So now it's false because Bob is not there. So those are the three operators: add, remove, and contains, that are the reason why you want to use a set. Those are the main methods for the set interface. There's a couple other ones. You can look those up, but that's the main thing. Okay, so Now we've been adding strings here. Okay, well, first let's talk about these three types: HashSet, TreeSet, and LinkedHashSet. So first thing to notice is I used HashSet there, but I could have used TreeSet, right? Save that. Well, I do have to import it, and then I can now run it, and it runs fine. And similarly, I can do LinkedHashSet. Save again. I gotta import it. Forgot that. Import it. So that adds the import statement up there. And there you go, it runs just fine. So why 3? Well, you'll notice if I do TreeSet, I printed out they appear in Alice, Bob, Charlie order, in alphabetical order. You know, I can move this guy down, move Alice down there, run it again, and they still appear in Alice, Bobby, Charlie order, or alphabetical order. While if I use the HashSet, I run it. Okay, you're messing me up. Yeah, it's not supposed to be like that. Alice. There. So Alice, Bobby, and Charlie. Using the HashSet, I run it, and they appeared not in alphabetical order, but Bobby appears first. So it's really unpredictable. With the HashSet, you don't know what order. You see, now she appears first. You don't know what order they're going to appear when you put them through the iterator. While with the TreeSet, they are ordered. So TreeSet, the iterator ordered by the comparator. Compared to. And while the HashSet, no predictable order. And the LinkedHashSet will list them in the order in which they are added. So that's useful. So the LinkedHashSet, save that, run it. Alice, Bobby, Charlie. So if I add Alice at the end and I run it, Bobby, Charlie, Alice. So it has the LinkedHashSet does have an order and it's different from the TreeSet. Now notice I said here these are ordered by the compare to operators. In this case, you know, it's a set of strings, so they're ordered by the string dot compare to. It's an instance method, a dot compare to this particular method, which is built into string, and in this case compares to strings lexicographically or alphabetical order. So now next thing, let's say you want to change. So we're storing strings, but in most realistic situations, you want to store more, right? So let's say you have a person class, and a person has a name and age and other things, occupation, etc. So I'm going to create a new class called person and finish that. And we're going to try to create a set of persons, right? So I'm just going to make this public for now. Public string name, public int age. We just keep it at 2, just to show person string name int age. This dot name is name. This dot age is age. And wait, what's wrong here? Okay, so I have a person, and now I'm going to go back to my main, and I'm going to change this from a set of strings to a set of persons. Person, person. This is going to be a person here, or so person. Also, I can't be adding strings anymore. I got to create 3 people. Person A is a new person, Alice, and B and C. B is Bob. So I'm just going to look at the names. Now I'm not care about the ages. That's just for show. Okay, so then I'm ready to add A, B, C. A, B, and C. So I can add those 3, and then now it's no longer a string, but it's a person. It's our name. It's a person. And then I want to print out the person's name, right? So and I'm gonna go for the TreeSet to start with. TreeSet to show you. So the TreeSet is ordered, and you'll see we got an error here. Person cannot be cast. Yeah. So this is what's gonna happen if you do that, and you're like, okay, well that doesn't work. Now notice that a fun thing. If you make it a HashSet, it works. Bam. And you're like, okay, awesome. So I can just make it a TreeSet, right? And then you got that error. But it tells you right here, you see the problem is person cannot be cast is not a comparable. So this is telling us that person has to implement the comparable interface. Comparable, right? So let's do that. What's the comparable? We can go back to person here and implements comparable. Save that, and then we do the command 1. Well, actually, we're going to do it here. Add unimplemented methods. That's going to add my compared to method. So the comparable interface only implements one method, which is compared to. And by the way, this should say we want to do that. Similarly, we want to change this object to person because we're using templates. There you go. Or generics, sorry. So templates in C++, generics in Java. It's a fairly similar idea. So yeah, we do that, and so all we have to do is implement this method compare to that takes a person and compares it. So we have to decide how we are going to compare people. Let's just stick to lexicographical ordering as we've been doing. So when I do that, I'm just going to return. I'm going to use the built-in compared to. Oops, the other is O. The built-in compared to method for string, right? So this compared to is the built-in string compared to, which compares to string lexicographically. So I'm just going to order people by their name. I could have ordered them by their age or something else, but for now, let's just order them by their by the name. So now, when I run this, it should run. Except it doesn't. I think I got an error here somewhere. It says Java compared to person can now be cast to Java language string. um, in line 26. So, oh yeah, so that was just an old code I had there. Get rid of that line because, again, set contains Bob is the problem. Bob is a string. I cannot make a string into a person. So run it again, and now it works. Now we're happy. So Alice, Bob, and Charlie are still sorted alphabetically, and there will be, let's say, for example, let's say I don't want to sort them alphabetically. I want to sort them by the length of the strings, right? So I can say int, my length name, equals, what the, equals name dot length dot length, and other guy length. Um, if O length equals my length, then return 0. If my length, forgot the parentheses, if my length is less than O length, then return -1, and otherwise return 1. This is how comparative works, right? If there's the same, you return 0 if they're the same, negative if this is less than the other, and 1 if this is bigger than the other. So when I run that, it's going to put them in order of the length of the number of characters in each name. So there you go. So that's how you do this. That's how you put a person or any class into a set. So the main thing to remember, if you're using the TreeSet, you have to implement the comparable interface. Now, there's a couple other things more advanced that will come to bite you if you don't know about them. Let's say, so here I'm adding A, which is Alice, and then B, and then C. Let's say I do an add A again. Right, so I add A. No, what I want to do is I want to add A, and then I'm going to change A's name to Bob. So that's the first thing I want to show you. If I run that, it well worked. Awesome. And if I change this to a HashSet, yeah, it didn't work. So why, right? So you're like, what? That worked for tree, it worked for TreeSet, and it didn't work for HashSet. What's going on here? Very confusing, right? And so the reason this is happening, so you see, we added A and then we modify it afterwards. Now, first thing is you should never do this, right? So just as a general rule, never do this. Person should be immutable if you can. Immutable. So immutable, remember, means that once I create Alice, I cannot change anything about her. Or at least I should not be able to change the things that we use for comparison, which is the key to this problem. You see, the TreeSet, the question is, how does the set compare two items, right? So when the set implementation, when you do an add A, the set implementation has to determine, is this A equal to this guy who's already there? Is it equal to this other guy? Is it equal to this other guy? Is it equal to this other guy? And so how does it do that? Well, the TreeSet is going to use your compare to method, right? So the TreeSet is going to use my compare to method. So that is why, compare to is going to say, it's going to tell me, hey, if two things have the same name right here, this line right here, well, I'm sorry, it's the same length in this case. Two things have the same length, then well, the name has the same length. Then they're the same thing, right? So two objects whose name has the same length are the same thing. I'm going to change this to the other one because before we just had compare to. So if we just had the original one, which is, compared to the two strings, again, we're saying if two people have the same name, then they're the same thing. I can run that again and see it still works. So we add A. What's going to happen is we add A, which is Alice. It's fine. Then we change Alice's name to Bob. And then we have B, but you see B is Bob. So B, the new B, is the same as the old A, so it doesn't get added. Then we add C, right? Notice that, even in this case, I can still change Charlie's name to Bob, and then I run that and I end up with two Bobs, right? So you can still end up with multiple Bobs if, your classes are not immutable. If they're mutable, if you change them after you add them, you can end up with duplicates. So mostly you don't do that. You don't change things after you put them in. Okay, but so that's why it works for the TreeSet, because the TreeSet uses the comparable. HashSet does not use comparable. HashSet, so the HashSet implementation, and as well as the LinkedHashSet implementation, they use the Hashcode. So what we need to do, if you wanted this to work, right, which you probably want to by now. So remember, if I run this, I get Bob, Charlie, and Bob, right? So the first one, I get two Bobs because the first one and the second one. So the first one is added is A, this Bob, and then the second one is B, and then the third one is C. So I don't want it, if I want it to be like before, that this one doesn't work. What I need to do is I go to personal.java, and I'm going to go into the source menu. I'm going to click on, you can't see that, but I'm going to click on generate hash code and equals. And I'm going to base it on the name, because that's, defining identity. So I base it on the name only, and you see it creates this two method, hashcode method and the equals method, based on name, other name, name, and you can look at that at your own time. But when I run that now, it still doesn't work. But if I get rid of this, like I said, you should never do that, and I do this instead. I'm gonna make two Bobs here. A and B are really Bob and Bob, and I run that, and it works, right? So you see, I created A and B, and they're both Bob. Even though they're two classes, they only get added once. And going back to person, if I were to get rid of these two methods that I just created, get rid of them. Bye bye. And run it again. You see that I get Bob, Charlie. So I get two Bobs. So if you get into that, the reason is because you need to define your hashcode method and your equals method, right? And you can see what's happening is it's a question of how do you define equals, like I said before, right? Now the HashSet defines equality using the equals method and the hashcode, right? So if two things have the same hashcode, they are the same thing. If two things are equal to each other, they are the same thing. So it uses both of these, at different times. So both of these have to be the same, really. But this is the generated code, and it works. You can see it's using the name. You could use any variable here in your class. I use the name. I could have used the age, and that would have meant that anybody with the same age are the same person, which doesn't make sense. Or you can use combinations of them. So instead of using just name, if you say name plus social security, so you can then expand this. It'll be a little more complicated, but you can do that. You can expand your definition of name to be, instead of name, is another method that returns a larger string that is the concatenation of the name and the social security number, or something like that. So those are things to keep in mind when using the sets. So to summarize, we have the set interface with 3 implementations: HashSet, TreeSet, and LinkedHashList. The last thing is the runtime. So you saw that the TreeSet iterator lists things by order, by the order that you give it in the comparator. The HashSet has no ordering, and the LinkedHashSet has the order in which they are added. Now, so if the HashSet has no predictable order, why would you use it? Well, because it's fast. So the HashSet has a constant running time. So basically that means that the add, remove, and contains operations run in constant time. So that means that regardless of how many items you have in your set, the time will be basically the same for adding, removing, or checking contain. Running these 3 methods will run in the same amount of time regardless of the number of items. While for the tree set, that is going to be order of log n, right? So n is the number of items in the set, and then the add, remove, and contains operations will take log n. This is lg, that's log base 2, doesn't matter. So log n of n being the number of items. So if you have really big sets, it might get a little bit slower, or if you have a slow machine like a handheld. The LinkedHashSet is still a hash set, so it's going to be constant time. But if you read the documentation, it'll tell you that this part here is slower. So they don't go into details as to how much slower it is. So actually iterating over the set is slower than in the tree set, where the iteration is faster. So just depends which one you need.